Hello students, last time we had seen the various theories associated with the structure of an atom. The first theory being Dalton's atomic theory. It was followed by J.J. Thomson's theory, then Rutherford's theory, followed by Rutherford's theory was Bohr's theory, and Bohr-Sommerfeld model, of course not there in the syllabus. This is what we covered in that lecture of atomic structure. 11th standard we have a lesson atomic structure in which you will be studying these topics in great details. This was introduction to the topics. What are we actually doing is whatever you have studied in 8th, 9th, 10th which we need for 11th and 12th, that is what we are revising through this. So what we will be doing today is we will be talking about the structure of the atom again. And in structure of atom we will be going in details of what exactly an atom is composed of. So when we say an atom, there is a nucleus, and as we know we have protons and neutrons which are residing into the nucleus. So nucleus consists of protons and neutrons. So protons and neutrons together are referred to as nucleons. That is, whatever stays inside the nucleus, that is what we refer to as nucleons. So protons and neutrons are referred to as nucleons. And electrons, as we know, are revolving in circular orbit. Of course, you have seen that the first orbit has a capacity of 2 and the second orbit has a capacity of 8 electrons. You see the formula 2n squared, where n is the orbit number. If it is 1 then 2, if it is 2 then number of electrons which can be accommodated in the second orbit is 8, and if it is 3 then 18 and so on. So fine, we know that the electrons are revolving in circular manner. Fine. We spoke about the electrical neutrality. We studied about the electrical neutrality of an atom. What does it mean actually? Is the atom has no charge. And the reason why the atom has no charge is because the total positive charge inside the nucleus is balanced by the total negative charge because of the electron. Fine. So what is the charge? So if I talk about proton, neutron and electron. Proton, if I talk in terms of charges, the charge on a proton is positive. It is written plus E. Charge actually is measured in coulombs and we write it as plus 1.6 into 10 raised to the power minus 19 coulombs. Neutron, discovered by Carrick, is a neutral substance, of course, so it won't have any charge. And electron, discovered by J.J. Thomson, has negative charge. We generally write that negative charge as minus E, and it is minus 1.6 into 10 raised to the power minus 19 coulombs. What we see is the charge on a proton is exactly equal to the charge on the electron, but one is positive, other is negative. So one proton and one neutron, if taken together, and if I ask you what is the net charge on a pair of proton and neutron, on a pair of proton and electron, it will be 0. Exactly the same way, in case of an atom, the number of proton is always equal to the number of electron. In an atom, the number of proton is always equal to the number of electrons. What does that mean? When I say that the number of protons are always equal to the number of electrons, it means that the total positive charge inside the nucleus is exactly balanced by the total negative charge which is circulating the nucleus. So obviously this means that the atom is neutral, no charge. The atom together has no net charge or zero charge. Fine. Once you understand this concept that an atom does not have any net charge, then the next stuff you have to understand is what about the mass? What about the mass of an atom? So, as we know that this structure, which is referred to as Rutherford's model of an atom, basically with some minor modifications done by Bohr, this structure is basically derived from the solar system. So exactly the same way, the entire mass of an atom, the entire mass of the atom is concentrated in the nucleus. The mass of an atom is because of the mass of the nucleus. The entire mass is supposedly concentrated in the nucleus. If you want to go into the values, then protons and neutrons at this level, we can say the mass of a proton is approximately equal to the mass of a neutron. Actually, the mass of a neutron is slightly greater than, the mass of a neutron is slightly greater than the mass of a proton. But to start with, we will say that the mass of a proton is approximately equal to the mass of neutron, which is 1.67 into 10 raised to minus 24 grams. Fine. This is what is the mass of a proton or the mass of a neutron. What is the mass of an electron? So, mass of an electron, extremely small. The mass of an electron is negligible as compared to this mass. But does it have mass? Of course it has. And the mass of the electron is 9.11 into 10 raised to the power minus 31 kgs. The mass of an electron is 9.11 into 10 raised to the power minus 31 kg. This is referred to as extra nuclear part. न्यूक्लियस को छोड़ बाकी हिस्सा जो है वो इलेक्ट्रॉन है. 11th और 12th स्टैंडर्ड में हम लोग सिर्फ इन्हीं 3 सब एटॉमिक पार्टिकल्स की बात करते हैं. सो द टॉपिक इन स्ट्रक्चर ऑफ एटम वाज सब एटॉमिक पार्टिकल्स. तो शब्द है, द वर्ड इज अणु फॉर एटम and this is parmanu. These are subatomic particles. Are there more subatomic particles than this? The answer is yes. There are gravitrons, there are mesons and all that stuff. But in order to understand the basics of chemistry, this is going to be sufficient for us. Now we need to know the distribution of electron and what do you mean by valence electron. For example, let us say you take an element. The element is suppose sodium. Atomic number of sodium is 11. We'll definitely go back to the elements, but try and learn the first 30 elements. I'll give you a trick on how to learn the first 30 elements of the periodic table. Sodium, atomic number 11, will have a centrally located nucleus. In which there will be 11 protons. And there will be 12 neutrons. In the nucleus of sodium, there are 11 protons and 12 neutrons. The first orbit of sodium will have couple of electrons. In the first orbit of sodium, there will be 2 electrons. That is the innermost orbit. That is what we call it. The second orbit, as you can see, will have 8 electrons. This is the second orbit. These are the inner orbit electrons, and the last orbit of sodium, there will be only 1 electron. This electron in the last orbit is the one which will actually take place in majority of the chemical reactions. This last orbit electron, in case of possibly all the atoms, this electron will be taking part in the chemical reaction, and this last orbit electron is what we refer to as valence electron. This last orbit electron is what we are going to refer to as the valence electron. So once you understand this topic very properly, then you can go ahead and understand atomic number. What do you mean by atomic number and atomic mass number? I am keeping everything on the board so that you can understand every single concept. time and again, over and over. That is, if I want to understand now the meaning of atomic number and atomic mass number, I have to go over here. Atomic mass number. The elements are generally represented by their symbol. For example, sodium, if I write sodium over here, it is Na. That is what we write sodium as. It's basically, the word is not coming up from English language, it is natrium. On the top over here, so this is the symbol of the element which we write over here. Over here, we write down something which is called as atomic mass number. We call it as atomic mass number. We refer to it as the atomic mass number. And over here, what we write is referred to as the atomic number. We call this as atomic number. So now what we have to study on the basis of whatever basics we have done right now is what do you mean by atomic mass number, what do you mean by atomic number, and what it signifies actually. So in case of sodium, how I write it is I write 23 over here and I write 11 over here. The atomic mass number of sodium, is 23 and the atomic number of sodium is 11. What does it mean? What does this represent? And what does this represent? Atomic mass number, the word itself tells you everything. It is representing mass. What is contributing mass? The subatomic particles which are contributing to mass are protons and neutrons. So atomic mass number is 23. It means that the number of protons plus the number of neutrons is equal to 23. Atomic mass number is nothing but the sum of atomic mass number is nothing but the sum of the number of protons and number of neutrons inside the nucleus. Obviously they are going to be inside the nucleus. Fine. So I understand atomic mass number means what? The word mass will tell me it represents the mass. The mass of an atom is contributed by proton and neutron. So it is the number of protons plus the number of neutrons. Fine, no problem. What do you mean by atomic number? Atomic number is nothing but the number of protons or number of electrons. Atomic number is nothing but the number of protons or number of electrons. It is 11. What does that mean? It means that in case of sodium, there are 11 protons and obviously there will be 11 electrons, because we know that the atom has to be ultimately electrically neutral. So number of protons and number of electrons should and must be the same. So what I understand from this is atomic number is nothing but number of protons or number of electrons, and atomic mass number, these are the symbols which we use, and atomic mass number is nothing but the number of protons plus the number of neutrons. So these are the fundamental concepts which if you are familiar with, then there is absolutely no problem for you to understand some very, very interesting terms which we will be using time and again in this syllabus. The term is, what do you mean by isotope, and what do you mean by isobar, and what do you mean by isotones? What do you mean by isotope, isobar and isotone? So let us talk about isotopes. Iso means same. Okay, so iso is same. Isotopes, then we will be studying isobars. Let us try and understand this one. Once you see an example, I mean that is the way we will be going ahead. We will be understanding the concepts with the help of the examples. Then only then the concept becomes clear. What's that? Isotopes of the same element. सब जगह oxygen है देखो. O and O. This is oxygen. जैसे this was sodium. This is oxygen. So isotope will be of the same element. Isotope of the same element will have the same atomic number. They will have the same atomic number, 8, 8 and 8. Of course we know that. And different atomic mass numbers 16, 17 and 18. Isotope of an element will have the same atomic number but will have different atomic mass numbers. Go ahead and understand what does it mean. So you will find something very interesting if you go ahead and try and check out what does it mean. It means that in this case, if I talk about this, okay, let me get rid of this. If I talk about this, the number of protons are how many? Number of protons are 8. Obviously number of electrons are going to be 8. Number of neutrons are going to be how much? Or how I'll find out the neutrons in this now. Now let us go back over here and try and find out how many neutrons in this. So people who have done their basics properly, they will immediately jump to the conclusion that if atomic mass number and atomic number is given, if atomic mass number and atomic number is given, then it is very simple to find out number of protons, number of electrons and number of neutrons. How? So atomic number itself is nothing but the number of protons and number of electrons. Then how will find out that the number of neutrons? Atomic mass number will give me the number of protons and the number of electrons. So I write over here number of protons are 8, number of electrons are also 8. Fine, no problem. How will I find out the number of neutrons now? For example, in this case, the number of neutrons will be given by 23 minus number of protons coming on the other side. This is 11 over here. The answer is 12. Similarly, over here, if I want to find out the number of neutrons will be nothing but atomic mass number minus the atomic number. So it will be 18 minus 8, that is 10. The number of neutrons are 10. In case of O18-8, this is what it is. In case of oxygen 17-8, the number of protons are going to be 8. Obviously, the number of electrons are going to be 8, and the number of neutrons in this case will be how much? It is 17 minus 8, and that is going to be 9. In case of this, number of protons are going to be 8, number of electrons are going to be 8, and number of neutrons will be how much? 16 minus 8, that is 8. So what I understand from this is something very simple. That is, if I have isotopes do not differ in anything else. Isotopes do not differ in anything else, but they differ only in the terms in number of neutrons. This has 8 protons, all these three, 8 electrons and 10, 9 and 8 neutrons. So isotopes of the same element have different atomic mass numbers but same atomic number. That is what the concept of isotope is. We will be using it in many of the situations over here. I've written isobar. Let me now talk about what do you mean by isobar. Isobar, it's exactly the opposite of isotope. Let me show it with the help of an example. I'll write potassium, calcium, potassium 19, 40, 20, 40. These are isobars. So isobars of different element. Isobars will be of different elements. Isobar of different elements will have the same atomic mass number, but different atomic numbers. Isobars have the same atomic mass number but different atomic numbers. There is another term. Now some questions I am giving you so that you can just go back and try out from internet, wherever you can. First question, what do you mean by isotones? So we'll start our next lecture possibly with the help of this. What do you mean by isotones? And is there any element in the periodic table? Second question, is there any element in the periodic table which has no neutron in the nucleus? I'll call it no neutron element. I'll call it no neutron element. Is there any element in the periodic table which has no neutron in it? So you ponder upon these two questions. What do you mean by isotones, and is there any element in the periodic table which does not have any neutron in it? Fine. So this is the second part which you need to understand before you see a very interesting and very important concept. Okay, and the concept we are going ahead with is what is a mole concept. Okay, so let us try and understand what is a mole. This concept is the fundamental part of the first lesson of 11th standard. I was going through the books and your 8th, 9th and 10th book, and the concept is out there. For understanding mole concept, first let us see what all we need to know. You should know, before we study mole concept, you should know what do you mean by Avogadro's number represented by N0. You should know what is Avogadro's number. It's a pure number. Its value is 6.022 into 10 raised to the power 23. In some books it is 6.023 into 10 raised to 23. Hardly makes any difference over here. So Avogadro's number is the first thing you are supposed to know. What is Avogadro's number? The Avogadro's number is 6.022 into 10 raised to 23. What is the significance of Avogadro's number, we'll see. But the second thing you are supposed to know is what do you understand by atomic mass number. So we already know what is atomic mass number. We are familiar with atomic mass number. Once you know these two concepts, Avogadro's number is this and atomic mass numbers concept, then the first part of mole concept is very simple. 1 mole of anything, please pay attention. 1 mole of anything, 1 mole of an element, suppose 1 mole of any element is nothing but 1 mole of element. 1 mole of an element is nothing but 6.022. 1 mole of a substance, let us call it to start with. 1 mole of a substance is nothing but 6.022 into 10 raised to the power 23. 6.022 into 10 raised to the power 23 particulates. Or 1 mole of a substance is nothing but atomic mass number in grams. Atomic mass number in grams. What do you mean by atomic mass number in grams? Let us try and understand this concept as well. If I talk about 1 mole of sodium, that is what we were doing. 1 mole of sodium. What is 1 mole of sodium? 1 mole of sodium will have 23 grams of sodium. Why? Because we studied just now that the atomic mass number, atomic mass number of sodium is 23. So 23 grams of sodium is equal to 1 mole, or 1 mole is equal to atomic mass number itne grams. Fine. So 1 mole of anything will be उसके atomic mass number के जितना ग्राम. अगर मैं एलिमेंट की बात कर रहा हूँ, मैंने यहाँ एलिमेंट लिख कर बाद में रब कर दिया, किसी भी एलिमेंट का 1 मोल क्या होता है, तो उसके atomic mass number जितने grams. Let us take another example. This is 1 mole of sodium. If I want to talk about 1 mole of let us say iron, 1 mole of iron will be 56 grams of iron. 1 mole of iron is equal to 56 grams. I hope you know that the atomic mass number of iron is 56, and therefore 1 mole of iron is equal to 56 grams of iron. It is equal to 56 grams of iron. So I understand the concept of 1 mole. 1 mole is nothing but 1 mole of an element. Let me write it over here then. 1 mole of an element is nothing but the atomic mass number, is nothing but the atomic mass number which is expressed in grams. It is atomic mass number which is expressed in grams. 1 mole of, let us take another substance, 1 mole of helium, suppose. 1 mole of helium. Helium is atomic number 2 and atomic mass number is 4. So 1 mole of helium will be 4 grams of helium. Will be 4 grams of helium. Fine. So the concept is 1 mole of an element is equal to atomic mass number itne grams. So what is this number doing over here? This is what we call as Avogadro's number. Avogadro's number का मोल से क्या वास्ता है? तो 1 mole of any substance. Now let us talk about Avogadro's number. 1 mole of any substance is equal to 1 mole of any substance is equal to Avogadro's number इतने particulates. यानी 1 mole of sodium is 6.022 into 10 raised to 23 atoms. 1 mole of anything, 1 mole of anything, 1 mole of atom over here is 6.022 into 10 raised to 23 atoms. 1 mole of sodium will contain 6.022 into 10 raised to 23 atoms of sodium. 1 mole of iron will contain 56 grams of iron, and there will be 6.022 into 10 raised to 23 atoms of iron. 1 mole of helium will correspond to 4 gram of helium and will contain 6.022 into 10 raised to 23 atoms of helium. This is the fundamental part of what we call as mole concept. We are right now studying mole concept only on these two grounds. There is another aspect to it, that is mole concept on the basis of volume, but that is what we will see next time. Right now I'll ask you another question. So we have the first question, that is what do you mean by isotones. Second question is what the element in the periodic table which is devoid of, which is not having any neutron. And another question is what do you mean by variable valency. What do you mean by variable valency? Fine. Variable valency का मतलब बड़ा आसान है. Variable यानी something which changes, और valency is how many electrons it can give or it can take. So third question is what do you mean by variable valency, and are there elements in the periodic table which have variable valency? The answer is yes, of course, and we have to find out the elements in the periodic table which have variable valency, the elements in the periodic table which show different valencies. This is what the third question is. So I hope that you will find out the answers of these three questions. Next lecture when we start, we will be answering these three questions, and after we answer these three questions, we will again go back to this concept of mole concept, and we will be going in details of mole concept. But just remember one thing as far as mole concept is concerned. Mole concept is the fundamental part of chemistry, and 1 mole of any substance consists of Avogadro's number itne particulates and 1 mole of any element, and 1 mole of any element is nothing but atomic mass number के जितने grams of that element. So if you put these two things in your brain properly, many of the numericals in chemistry will be sorted out. Okay, thank you for watching this sincerely and seriously. Please make sure that you are attending all these demo lectures which are conducted by all the faculties. In the next lecture, we will be going in details